Hey. So today we'll be talking about culling, specifically area-based culling. Now we'll be examining two specific methods, and I won't bore you with an explanation. I'll just show you. Let's get right into it. So, first things first, we're standing on a quad right now. Now this little quad here is just here to visualize a boundary. Now this is a 10 by 10 quad. So that means that from 0, this goes to 5 to -5 over here, and +5 and -5. It's essentially 5 in all directions from 0. Now, what we want to do here is we want to make it so that this little torus here is only visible when we are in here, but not when we're over here. Now, the one big thing about this culling method that we're about to be doing here is that this is not dependent on three-dimensional space. It is purely two-dimensional. You could make it three-dimensionally too, but for 3 dimensions, we will be taking a look at this cube over there next. So first things first, now that we know that it goes to 5 on either direction, what we'll do is we'll open up Flux real quick, and we'll mathematically define that, because it's very simple mathematically. We'll go to operators, and we'll go to packing, and we'll get a pack free of type float free, and we'll get an unpack free of type float free. Now, this allows us to, for example, make a float like 5 by 5 with a y of 0. Now we could also simply define it like this, but we'll need this node either way. So first things first, we know that we need to go 5 positive and 5 negative. So we know that we need a negative version of this already. The way we get that is by simply getting the value negate of type float free, but I'll just do float 4 because it's the first one I saw. So by putting in 5, 0, 5, we get -5, 0, -5. Now, once we have that, we'll need some itty-bitty math. Specifically, we want to know if something is in between this value or its inverse. So what we have to do is we have to go to math. And in here we actually have is between. Again, we'll just get a random one because the moment we hook it up, it'll just invert. It'll just correct itself. So our minimum is going to be the inverted value, and our maximum is going to be the base value. So now we can get a value here of true or false, whether something is within that range. So if we, for example, set this to 6, 0, 0, 0, it's going to be outside of its range. 4 is inside, 4 is inside, and then the y here is another value that is supposed to be 0. Now, one big thing about this area-based part here is that it actually allows you to make what is called layers, or culling layers. This means that since we're not going to be working with three-dimensional space, this means this three-dimensional value y here, we actually can freely control to set it to different things, which is why we have this up here, so that we could actually flip this to a 1, for example. Now, if we do this, we also don't want to flip, of course, everything. We just want to flip the values that are, in fact, needing to be flipped. So that would just be the 5. So we'll actually just flip the 5 and keep the y value unmodified. So let's rehook this up by simply moving that over like this, getting another input for this, hooking up the 5s down here. So we have the positive and the negative. So then this is the +5 and this is the -5. All right. And this is actually already essentially almost done. I'll actually destroy the unpack, but we do need the unpack because the next thing we'll be getting is a little user value, and it's a local output. Specifically, it's going to be our view position. Now, this view position will unpack, which will get us the X position, the Y position, and the Z position. Now, the Y position we don't care about because, as we talked about before, that is simply going to be our own little value to determine what layer we are on. However, we'll also only be working with one layer for today, so just keep that in mind. Now that we have these values, we can repack it back into this value here. And once we pull this out, you can see our Y value is now 0. And if we put this into here, we'll see it's false. But if we walk over this quad, it turns true. The moment we're back over here, it's false again, true, false, true, false. Now, what we'll have to do is actually make use of this. So I already made this slot here called world root that is underneath the actual root. So we'll make a slot here and call this call controller. Make another child and call this area 0. And simply grab this and pack it into here. Next, we'll make a slot here and call this area 0. Because this here is our controller for area 0, and this is the actual area 0. So now in order to hide this torus, it needs to, of course, be inside of area 0. So we'll parent it into area 0. We'll unpack the controller for area 0, grab the active state of area 0, and then drive it based off of this is between here. Once we do that, we can simply repack it back into the controller. So now there's no more torus. If I walk into here, there is now a torus. Walk off, no more torus. Torus, no torus, torus, no torus, torus, no torus, torus. If I grab the torus and I move off, you'll see it's still there because it's currently under my hand. If I let go, no more torus because it's back in area 0. All right. This is how this type of calling works. Now, you don't need the squat on the floor. This is purely just visualization purposes so that you can see that this is essentially what a 5x5 in either direction from 0 looks like. Next, over here, we'll want to hide this little cone unless we are inside of this box. First things first, we'll simply go to our dev tool, select the box, go to Open Inspector, and we'll want to change the box collider here from static to trigger. Once we change this to trigger, you'll also notice that we no longer see our laser colliding with it. If you saw my laser, one moment, there we go. So now you can see my laser is not colliding with this. If it was static, it would actually collide with my laser. Now, we can get rid of the grabbable or simply disable it. And then we'll make a little slot here and just call this area. So we have our actual calling box here, and then we have the area beneath it. Then we grab this cone and we parent it into the area. Now, once we have this, we can go back and select the box. And this is actually going to be a pure component setup. So we'll just go to Attach Component, Transform. Actually, not Transform yet. we'll go to, where is it? Physics, utility, and then there's the collider user tracker. Now, this simply defines whether a user is inside it or not. So if I walk into this box now, you'll see it will show my user on this little list here. All right. And that's pretty much our setup, because all we have to now do is grab is local user inside, go to area, drop it onto the active state, and drive it. So now our cone is gone, but if we walk into the box, the cone is back, it's gone, it's back, it's gone, it's back. And that's really how simple it is. Yeah. Now, you can use the collider user tracker with more complex meshes if you're using convex holes. You could use other shapes than a box, of course. However, that's simply as easy as just swapping out what your collider is that is on the same slot as the collider user tracker. Just make sure it's set to trigger, otherwise it won't work properly or will be not as efficient. I think an active collider may actually work too, but you shouldn't use active because, yeah, it doesn't even work because the collider user tracker doesn't recognize it. Let's see if we disable triggers only. Yeah, so see, even if we disable triggers only, active colliders don't even work, and they're a lot more processing intensive. So there's no reason to ever set it to active. Just make sure that it's set to trigger. I think static trigger also works perfectly fine. Yeah, static trigger also works. So either trigger or static trigger are going to be your go-tos for this method. But yeah, this is 2 ways that you can do area-based culling or zone-based culling. I hope you enjoyed this video, and I'll see you next time. Bye-bye.